Hi, welcome to online tutorial series on Arduino and IoT. This is lesson 8 and in this lesson we will talk about IR sensor interfacing to Arduino Uno. And further we also provide online training and help in technical assignments, and we also do freelance based project based on embedded system, MATLAB, LabVIEW, data science, Python and machine learning. So if you have any such requirement, then you can contact us at through our website, which is www.jcbrolabs.org, or you can also mail us at jcbrolabs@gmail.com. Okay, so let's start. When we talk about sensors, so in this video we are talking about sensors. So when we talk about sensor, so there are two categories of sensor. One is the digital sensor and the another one is the analog sensors. Okay, let's stop this video. Okay, so this digital sensor gives output in a form of 0 or 1, while this analog sensor gives output in the continuous voltage term. Okay, so in this video we will be dealing with the digital sensor, and specifically we will be talking about IR sensor. So prior to moving forward an IR sensor, let's talk about or a little discussion about its construction or how these IR sensors are made. Okay, so this IR stands for infrared sensor. So basically there are two common component in IR sensor. One is the IR LED. So it is like normal LED, only difference is it emits the radiation in infrared domain, which are not visible to human eye. But if you see this LED through the digital camera or the mobile camera, then you will be visualizing it. Okay, or you will be seeing the LED is on or off. And so this is one part is IR LED, and the another part is the photodiode. So photodiode is generally connected in a form of reverse configuration, so like this. So it could be in any one of the domain, like photodiode right now is here. So we can have the alternate configuration in which first we have a photodiode and then we have a resistance. So these both are valid configuration. The only difference is at the output, and we take the output from here. Okay, so as we know, as soon as light incident on this photodiode, this is photodiode, it starts conducting, right? So if light is incident on it, it will start conducting. That means the resistance of this photodiode will be less. Okay, so let's take a case when there is a dark, so it is not conducting. This output will be VCC, and now assume that light is incidenting on it, or light is falling on this photodiode, so it is conducting. That means the resistance of this photodiode is decreasing. So if the resistance is decreasing, the voltage across it will also keep on decreasing. So we can say the voltage across this V out, or we can say this V out is a function of light intensity. Okay, so if we draw a rough curve, it goes like this. So we came to know, so if we are taking this output from here, this is a continuous function of the light. So in this case it can act as an analog sensor, but now we want to make it a digital sensor. So what we'll do, we will feed this voltage to an op-amp. So the op-amp could be plus or minus, or in positive configuration or in negative configuration. So we have connected right now in invert configuration. So inverted op-amp, so output voltage depends on this V reference voltage. Reference voltage means, suppose if we have connected this to VCC, and this to ground. This is R1 and R2. Okay, so this V reference will be equals to R2 into VCC divided by R1 plus R2. So as you are familiar with the op-amp working, so if the voltage across this point, we can say this is VO dash, we can connect resistance or not, we can choose. So if this VO dash is less than V reference, then our output will be 1. That means we will get the positive output. And if this VO dash is greater than V reference, then the output will be 0. That means the plus VCC, or this VCC is the power supply of this one. So if this is VCC and the another point is connected to the ground, the output is plus 1, that means plus VCC and the 0. So this is how this simple IR sensor works. So what we do, we connect these IR or photo pair as it is and adjacent to each other, and then make this whole circuit. So if we look at the circuit of this IR sensor or the picture of this IR sensor, then it will be more clear. So let's have a look. IR sensor. So generally this is the IR sensor which we used for Arduino interfacing. So one is the IR LED and one is the photodiode, and they are connected to each other. So if any object is coming in front of it, if there is no object, no IR radiation is coming back to the photodiode, and this sensor will give the 0. And if something is in front of it, it will start reflecting back to the IR radiation will start reflecting back to the photodiode, and it will start working on this principle which we just discussed. Okay, so I hope you got it how this IR sensor is working. So you can also, if you have any doubt on it, you can also let us know by commenting below this video. Now let's have a look. Okay, prior to looking at the hardware, let's say how we are interfacing it. So in our hardware, for hardware demonstration, we have Uno board. Okay, and then with the Uno board, we have connected this IR sensor because this is the V out and this is IR sensor. It is connected to the pin number 12. Okay, and in order to visualize it, what we have do, we have used the previous circuit which was the DC motor. So our DC motor is connected to pin number 9 and pin number 10. Okay. Yes, pin number 9 and pin number 10, and there is a driver IC which we discussed in our previous video. So this is L09 3D, and then we have a DC motor here. Okay, so this is going to pin number 2, and this is going to pin number 7, and this is pin number 3, and this is pin number 6, and all other connections which we have already discussed in our previous video. And there is a one more LED is here. Okay, and we have connected to LEDs as well, in order to just to show whether it is displaying something or not. So this is our hardware connection which we have made, and let's have a look on the real hardware which we have created. This is our setup for IR sensor interfacing. Here's the IR sensor. So if some obstacle is coming in front of it, it will give +1, and otherwise 0. So let's see, if this hand goes near to him, it gives 1, and it indicates by turning on this red LED. So it has been powered with VCC and ground, and then output of this sensor goes to the Arduino pin number 12, this one. And we have also made a circuit like this. If if some obstacle is in front of it, it should stop, and otherwise motor should turn on. So motor is also interfaced with this Arduino Uno. And for more connection of this DC motor interfacing, you can go through our previous video in which we talked about it. Okay, so let's have further discussion about the programming of this IR sensor interfacing. Okay, so you have seen the hardware. Now let's write a program to interface this IR sensor, or to do certain working based on the command of this IR sensor. So let's first open this Arduino IDE. Okay, so we have connected pin number 8 and 9. These are pin number 8 and pin number 9, not the 9 and 10. These are pin number 8 and 9. Okay, so first task is to create a new file. So let's create a new. Okay. Now we have to define the, let's define the variables. First define the file name. Okay. Now let's define the file name. We have two input. We are taking as an input 1 for DC motor. So in 1 is pin number 8, and let's define IN2 as pin number 9, and let's define the IR sensor which we have connected to pin number 12. And let's define a variable which will be used to store the value of this sensor. Okay. Now we will also sending the status of the sensor to the serial port. So let's define serial serial dot begin 9600, and then define the pin mode. Because DC motor is as an output device, so IN1 and IO2 has been set as output, and IR sensor, we are going to read the data from this IR sensor, so this IR pin has to be defined as an input pin. Okay, so let's save it. Now there is a simple command to follow. We will be reading the status of the IR sensor, and then it is very much similar to the switch interfacing. In the switch interfacing, we will reading the switch status of the switch. Similarly, this IR sensor is acting as a wireless switch. So if there is something in front of it, will turn on, otherwise it is off. Okay, so we will read the status of the pin. It will read the status, and if it is 1, A will go to 1, otherwise 0. So if there is something in front of it, we should turn off the motor, and if IR sensor is not giving any 1, motor should turn on. Okay, so we use if else statement. So if this sensor will give 0 if there is nothing in front of it. So when there is nothing in front of, we should turn on the motor. Okay. Digital write IN1 comma high, and then one point should be turned high and another point should be low, only then motor will run. And now send some message to the serial port. Okay, and in the else case, let's make a else case. And let's provide some delay as well, otherwise it will be very nasty. So it seems fine. Let's compile it in order to check any possible error. Okay, it seems like there is no error. Code looks fine. The port is connected, so let's download the code. And in the meantime, let's open our screen camera. Yeah. So now you are visualizing the motor as well as all the connection to it. The circuit is shown here. Now when there is nothing in front of it, yep. So let's turn on the power supply to motor. It is off. Okay. Now when there is nothing, the motor is running, and this LED is also indicating that motor is running, and as soon as there is something in front of it, it will stop. Okay. So it's cool, I think. Yeah, we are able to control the motion of the DC motor based on the sensor. Yeah, one more thing which is very interesting with respect to this IR sensor, if there is a black surface in front of it, it will not detect it. Like this wire is black in nature, right? So it is not detecting it, it is showing there is nothing in front of it. So because the black absorbs all the light, so it is not showing anything. But as soon as I put it towards the table, it will start indicating, okay, there is an obstacle in front of it. So this is one of the very crude drawback. So this IR sensor is a very crude sensor for obstacle detectors, so for which it can be used. So it is detecting the table but not this black wire. Okay. Similarly, if we are able to get the some analog data out of it, right? So it will also be able to we can also make it to change the voltage as per the color. Okay, one more thing with this IR sensor, if you are trying to use this particular sensor module in front of a sunlight, then your sensor module may not work properly, because there is a lot of stray IR radiation in sunlight, right? So your photodiode may detect as a stray IR radiation, as a radiation coming from the IR LED. So in that case, if you want to use this particular sensor in open field, so you may have to recalibrate the sensor. So in order to recalibrate it, just you have to change this particular the potential V reference value. So which that reference value can be changed from this potentiometer. So that is what only you have to do. Okay, so that's fine. If there is in front of it nothing, if there is nothing in front of it, it is showing. So there is a delay in between because we have provided a 1 second of delay. So it's cool. Okay, so you can create several cool applications based on this. So I hope you like this video. So in our next video we'll be talking about a project which is the obstacle avoider robot with the help of these IR sensors. So we'll be connecting two DC motor and the two IR sensor, and then we will be performing certain tasks of obstacle avoidance in a case of robot. So I hope you like this video, and if you have any suggestion and any doubts, you can let us know by commenting below this video. Okay, so further we also provide online training and online tuitions. We also do help in technical assignments and do freelance based project based on the latest technologies like MATLAB, LabVIEW, Python, data science, machine learning, etc. So if you have any such requirement, then you can let us know through our website, which is www.jcbrolabs.org. You can also drop us a mail at jcbrolabs@gmail.com. So that's it for this video.